Hello everyone, this is Chinnaiah Kalpana here. In this video we are going to see a problem from partial differential equations. So let's get going. Problem: form the partial differential equation, it's equation, okay, of all planes through the origin. So we are asked to find a partial differential equation of all planes through the origin. Okay, we know that the general equation to a plane is ax plus by plus cz plus d equal to 0, right? Here we are asked that to find partial differential equation of all planes to the origin. We are asked to find PD from all planes through the origin, which is nothing but all planes which passes through the origin, right? We know that is the origin, right? Coordinates at origin, say O. Okay, this is coordinate at origin, and equation passes through it. Since all the plane passes through origin, so if this equation passes through it, I am writing the equation again. If this passes through origin, then substitute the values of coordinates here. Which gives us 0 plus 0 plus 0 plus d equal to 0. From this we can say that d equal to 0, right? Now put this d equal to 0 in this equation, then this equation becomes ax plus by plus cz plus 0 equal to 0, which gives us ax plus by plus cz equal to 0, which is a required equation, not PD. This is the equation of all the planes which passes through origin. Okay, now from this equation we need to form partial differential equation. Let's see. We know that the general solution, the general equation to plane is ax plus by plus cz plus d equal to 0. Consider it as equation number 1. Since 1 passes through origin, then 1 becomes a into replace x by 0, y by 0, c by 0. Since we have coordinates at origin, which is 0, 0, 0, right? This gives us 0 plus 0 plus 0 plus d equal to 0. Again, this gives us d equal to 0. Therefore, d equal to 0. Now substitute this d in equation 1. Again 1 becomes, you have to write from 1, okay, let it be. Okay, now 1 becomes, just substitute the value of d here, you'll get ax plus by plus cz equal to 0 comes it as equation number 2. Now we'll form the partial differential equation from this equation, which is an equation of all the planes passing through origin. Okay. See, we are asked to form partial differential equation of all the planes which is passing through origin. Since we are asked to form from all the planes, okay, so that we have taken or we have considered the general equation of plane, right? And also we are given a condition that it passes through origin. So we have shown that it passes through origin. From this we got the value of d. By substituting it, we'll get this equation. Okay. Fine. Now from this equation only we need to find the partial differential equation. Okay. Not from the equation 1, since we are given that all planes passes through the origin. Fine. Now coming to the problem. Partially differentiating with respect to x. So I'm going to apply dou by dou x on both sides of equation 2. You can skip this step if you feel it's avoidable. See, here we are partially differentiating with respect to x, so y will be treated as constant, right? Now we can write this as dou by dou x of first term. You can also skip this step. Dou by dou x of second term plus dou by dou x of third term equal to partial derivative of a constant with respect to x is 0. Here a is constant, we can write it as a into dou by dou x of x. Here both are constant, so partial derivative of constant with respect to x is 0, plus here c is constant, you can write it as c into dou by dou x of z. Equal to 0. A into partial derivative of x with respect to x is 1, plus c into dou z by dou x equal to 0. Since we have a notation dou z by dou x equal to p, so let's replace dou z by dou x here. You'll get a plus cp equal to 0, right? Or you can write a equal to minus cp. Consider some equation number 3. Now partially differentiating 2 with respect to y. Since we are partially differentiating with respect to y, so x will be treated as constant here. You can avoid the first 2 steps. You can just skip this 2, okay? Dou by dou y of by plus dou by dou y of cz equal to partial derivative of a constant with respect to y is 0. Partial derivative of constant with respect to y is 0, plus here we can write it as constant b into dou by dou y of y plus partial derivative of constant with respect to y is 0 equal to 0, which gives us b into partial derivative of y with respect to y is 1. Sorry, here you are having z, right? So you can't write it as 0. You are having variable z, where z is a dependent variable. X and y are independent variables, okay? Or we can say z is a function of x and y, where x and y are independent variables. Fine. Now we can write this as constant c into partial derivative of z equal to 0 plus c into dou z by dou y equal to 0. Since we have a notation dou z by dou y equal to q. Let's replace it. We'll get b plus cq equal to 0. From this you'll get b equal to minus cq. Consider as equation number 4. Now observe 2, 3 and 4. You have a equal to minus cp and b equal to minus cq. So you can substitute 3 and 4 in equation 2. Let's see what happens if we substitute 3 and 4 in 2. We have equation 2, that is ax plus by plus cz equal to 0, right? Substitute a equal to minus cp and b equal to minus cq in it. Then this becomes a into, sorry, you need to substitute a, right? Minus cp into x plus b minus cq into y plus cz equal to 0. This gives us minus cpx minus cqy plus cz equal to 0. Okay, now I'll take these two terms to RHS so that I'll get cz equal to cpx plus cqy. Then take c common from the two terms of RHS. Then z equal to, now take this c to RHS, you'll get px plus qy by c, right, where c gets cancelled and you'll get z equal to px plus qy, which is the required partial differential equation. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.